So the first thing here we're going to do is we're going to review how to graph lines using two different methods. The first method is going to be using slope-intercept form, which is when y is isolated. And to do that, we start by graphing. We begin first at the b value, which is that number that's being added or subtracted, and then we rise and run according to our slope. So it'll be important that our slope is a fraction. So I'm going to do two examples with you, and then I'm going to pause the video to let you do the remaining four on your own, and then you can press play to check your answers to make sure that your answers are correct. So first thing we want to do is we want to identify the slope and the y-intercept. So our slope is always going to be our coefficient of x. So for our first example here, my coefficient of x, it looks invisible, but it's really that number 1. And then my y-intercept is always that number that's being added or subtracted. So in this case, that's going to be -6. So the first thing I'm going to graph is a y-intercept of -6, which means it has to be on the y-axis, and it's going to be on the y-axis at -6. So I'm going to go down 6. 1, 2, 3, 4, 5, 6, and I'm going to put a point there. Then, because my slope is 1, if I make that a fraction, to make anything a fraction, I can put it over 1. That means my rise is 1 and my run is 1. So I'm going to rise 1, run 1 from my y-intercept. So I'm going to go up 1 over 1. And then I'm going to put a point. I'm going to do that over and over. Up 1 over 1, up 1 over 1, over and over and over. And then I'm going to put a line through those points. And so that's how I graph using slope-intercept form. So on number 2, again, I'm first going to identify my slope. My slope is always my coefficient of x, so -1/2. And then my y-intercept is going to be 4. So I'm going to start by graphing my y-intercept of up 4. 1, 2, 3, 4. Put a point there. Now it's important to remember that when I have a slope that's negative, I need my line to be going down as I read it from left to right. So this can be confusing because this negative sign, sometimes we forget, like, okay, is the 1 negative or is the 2 negative? Well, only one of them is negative. So what I like to do is I actually like to write that negative sign with the rise. And so what this means to me is that I'm going to rise down 1, but I'm going to run +2. So from here, I'm going to go down 1, but then right 2. And then I can see how connecting these points would make it a negatively sloped line. Oops, that one was wrong. So I've got that. And so then I can go up 1, left 2. And so now I can connect with a line like this. So that's graphing using slope-intercept form. So what I want you to do right now is I want you to pause the video, and I want you to try graphing examples 3 through 6. I want you to start by graphing the y-intercept first, or b value, and then rise and run according to the slope. Pay particular attention to the sign of the slope to make sure if it's negative that your line is a negative slope. And then when you're ready to check your answers, press play. So on this one, we've got a slope of 2 and a y-intercept of -5. So we're going to start at down 5 on the y-axis, and then we're going to rise 2, run 1 to get to each point, and then connect with the slope. It's a positively sloped line. On the next one, we've got a y-intercept of -1, so we're going to start down 1, a slope of 3, so that means we're going to rise 3, run 1. So from here, we're going to go 1, 2, 3, 1, 1, 2, 3, 1 to get to all the other points. On number 5, we've got a y-intercept of 5, so we're going to start at 5. The big thing here is our slope is negative, so our line should be going down from left to right. And here we're going to rise down 5. 1, 2, 3, 4, 5, run 2. 1, 2, 3, 4, 5, run 2 to get our negative slope line. And then on number 6, we've got a y-intercept of -2, so we're going to start down here, and we're going to rise 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3 to get our positively sloped line. So these are a little different because now y is not isolated, so it doesn't make sense to graph using slope-intercept form. I could get y by itself by minusing 2x and then dividing by 3. Some people like to do that. Or I could do x and y intercepts, which is what I'm going to do. So an x-intercept means it's on the x-axis, which means it's not up or down, so my y value is 0. So if I were to take this 0 and plug it in for y, what would happen is I would get a mini equation that would say 2x equals 12. Because if I were to do 3 times 0, that would go away. Divide both sides by 2, and I would get x equals 6. So I get an x-intercept of 6, 0. If I was going to do the y-intercept, that means that the x is 0 because it's not left or right, so I would replace x with 0. And then because 2 times 0 is 0, that would give me a mini equation of 3y equals 12. And then if I divide both sides by 3, I would get y equals 4. 1, 2, 3, 4. And then I would connect those 2 points, probably using a ruler. If I were to do the next one, same thing. If I were to replace y with 0, my mini equation would be 8x equals 16. Divide both sides by 8, x would equal 2. So I would get 2, 0. And if I were to replace x with 0, here's the thing on this one, I would get negative 4y equals 16. Divide both sides by negative 4, and I would get y equals negative 4. So I just have to make sure I pay attention to the sign there. And I would get a line that looks like this. So I'm finding 2 points in the line. They just happen to be one of them on the x-axis, one of them on the y-axis. So pause the video, try examples 9 through 12, press play when you're ready to check your answers after using x and y-intercepts to graph your lines. So if I were to look at this first one, if I change y to 0, I get negative 3x equals 12. Divide by negative 3, x would equal negative 4. If I change x to 0, I get 4y equals 12. Divide by 4, y would equal 3. 0, 3. Connect them here. Here, if I were to do this, so if I change y to 0, I get 4x equals negative 20. Divided by 4, x would equal negative 5. And then if I were to change x to 0, I get 5y equals negative 20. Divided by 5, y would equal negative 4. Here's my line. Change y to 0, 3x equals 12. Divided by 3, x equals 4. And if I change x to 0, 6y equals 12. Divided by 6, y equals 2. Here's my line. If I change y to 0, 10 divided by negative 2 is negative 5. And if I change x to 0, 10 divided by negative 5 is negative 2. So these are my lines using x and y intercepts. We're going to use this concept in a moment when we get to graphing inequalities.